Hi there everybody, today we are going to look at differentiation 2. So this is the second lesson of 3 which talk about differentiation. Okay, so what we've seen already with differentiation is differentiating the value of y with respect to x, but of course not everything is that straightforward or I'm not going to say that simple, but of course in real life we have different things taking place, and some things increase in size or pace can be considered going up or down, i.e. a gradient. So what we call that is if something's increasing or decreasing in size, we would say that it's changing with respect to time, but ultimately we would call it a rate of change. Okay, so hence the kind of the terminology you've already kind of come across just a minute ago. So for example, if you've got a formula for velocity v with respect to time, we could find the rate of change of that velocity with respect to time by differentiating it, and we would say dv by dt, all right, in this particular case, because we've got two different letters. What we do in terms of the mathematics is very much the same, but we call it rate of change because it's specifically related to basically v and t, and especially t because it's about time. It's the rate of something happening. Okay, so let's look at a couple of examples. So you're given a formula v is equal to 2t cubed minus 5t plus 2, and can be used to calculate the volume of water within a container at any given time. All right, so that's the scenario. We're talking about volume and time, and the question would be is find the rate of change of v when t equals 4. Well, it's very similar to what we've done before with differentiation, other than it's saying find the gradient of something when x equals 2, I think was the original one, and we're now looking at the rate of change of v when t equals 4. So we're still going to differentiate this, but of course notation is a little bit different because we've got the v on this side and t. It's not dy by dx, it's dv by dt. Okay, so dv by dt follow the same process. So we're looking at bringing the 3 to the front and times it, so it's going to give us 6, and then t, and then we know we drop this by 1, so squared, so 6t squared we've got over here. And again, this is t to the 1, we drop it down to 0, which basically disappears, and then we've just got the minus 5. All right, so that is our rate of change at any particular point, but we want to find it what it is when t equals 4, so we're just going to substitute that value in. So when t equals 4, substitute in 6 times 24 minus 5 is going to give us 91. All right, and that is our rate of change. You'll notice on this particular example there is no units provided, so really we would need something a bit more in the question to talk about finding either an expression for the rate of change, which is going to be this, but if we're actually looking for a specific value at the end, we would hope there would be some kind of units involved, i.e. the volume in centimetres cubed and the time in seconds, so we can see that it's going up at centimetres cubed per second. All right, because again it's a rate of change, so we'd expect to see units in a particular question normally. All right, let's have a look at another example. So here it's worded a little bit differently, but same concept. So relationship between a and r is given by the formula a is equal to 3r squared, and calculate the rate of change of a when r equals 3. Now again, this could be the area and radius, you would think, thinking about those letters provided, but we're not worried. We're just going to use the same kind of terminology and same process that we did before, but keeping the letters in mind. So we're going to do dA by dr. All right, so differentiate the rate of change, so dA by dr, and this is a little bit simpler because we don't have much on here. So the 2 comes to the front and it becomes 6r, and when r equals 3, well, like in the previous one, we're just going to substitute the value of r into here, which is going to give 6r, which of course is just going to give me 18. So the rate of change in this particular question is 18, but of course we're missing what that actually means in terms of units because we're not provided with any, so that's as much as we can do at this particular point. All right, so rate of change is relatively straightforward. It's just differentiation, and it's just differentiation with essentially different letters. Okay, but you must be mindful of units if they are required or given in the question. Okay, so let's look at increasing and decreasing functions. So this is kind of spans into two parts. So if a function is increasing, what we're saying is gradient is bigger than 0. It's going up, isn't it? If a function is decreasing, then the gradient is negative. It's less than 0. And you can see that notation written here. dy by dx is greater than 0, and dy by dx is less than 0. All right. Because these are inequalities, we would need to give our answers probably in inequalities, if that makes sense. It really kind of depends on the question as to whether or not we need a range of values to answer the question. Okay, so let's have a look here. Right, so here it asks you a curve is given by the equation y equals x squared minus 6x plus 2. So you've got a nice little quadratic. So a quadratic, which will probably go like this, because it's positive x squared. And it says find the value of x for which y is increasing. Well, considering this kind of shape here, it would be increasing when it goes up onto this bit here. All right, because this bit's going to be positive, whereas this bit is going down, so it's negative. So it's going to be that bit at the end. All right, so we just need to find the values. All right, so really, what I want to find is actually when the turning point is, because it's going to be anything bigger than that. Okay, so let's differentiate this one first of all. So we've got y equals x squared minus 6x plus 2. So we're going to differentiate it, and it gives us 2x minus 6. But what we are saying here with this 2x minus, now this is the gradient. What we're saying that this bit has to be positive because it's increasing. So this is where we introduce the inequality. It must be greater than 0. Okay, so 2x minus 6 must be greater than 0 because it needs to be increasing. And then we solve the inequality, essentially. So we take the minus 6 across, so 2x is greater than 6, and then divide by 2, so x must be bigger than 3. So what we're saying is that the turning point probably is when x is 3, but anything bigger than 3, and it's going to be increasing. All right, and that is going to give us the value we need. So find the values of x for which y is, well, anything bigger than 3. Okay, so that's going to be our solution for that particular question. Let's have another look at another one. So a curve is given by the equation equals 4x squared plus 7x minus 2. So very, very similar in terms of the process, but this time we're looking for the values of x for which y is decreasing. So rather than being greater than 0 here, it's going to be less than 0. Okay, so let's differentiate it first of all. So differentiate y equals 4x squared plus 7x minus 2 becomes 8x plus 7, so the 2 comes to the front and drops by 1, and then of course we've got 7x, which just becomes 7. And then we now introduce the bit where it says less than 0, so x plus 7 is less than 0. Take the 7 across, becomes minus, divide it by 8. So we're saying x must be less than minus 7/8, and that would be our solution for this particular kind of question. All right, so not overly difficult. It's very similar to previous kind of solving inequalities. So if you haven't looked at that lesson, please do. But we're also introducing this idea of differentiating it as well. And of course, the wording is something that you just need to be mindful of and maybe not familiar with, but over a period of time you will become more familiar with. So what about quadratics? Okay, well, quadratics, it's kind of same idea. So an increasing and decreasing function where it's going to be less or greater than 0, but you might have to solve a quadratic inequality at the end to get the range of values. Okay, so an example is probably a good thing to look at in this particular case. So if you've got an equation which is a cubic, it often kind of goes in this kind of shape. All right, so it kind of goes up and down and up. So it increases at one point, stops, and then goes down, and then increases at another point. So there's going to be two areas of the curve where it's going to be increasing, and that's what we've got to determine. But the process is the same. We need to differentiate it, and then we need to solve the quadratic inequality. So let's differentiate it first of all. So 3 comes to the front, which gives us 3x squared. The 2 comes to the front and cancels out this 2, so we've just got 7x, and then we've got the minus 6. And we're kind of hoping at this particular point that when we introduce the inequality here, and again, because it's increasing, it's going to be greater than 0, that this part is going to be nice. We're kind of hoping that this is going to be able to factorize to provide us with reasonable numbers. That's the ideal situation. Now, it's highly unlikely that you're going to have to use the formula, but obviously it could be there if the particularly mean, but we're hoping it would factorise, and of course this one does factorise, and it goes into this double bracket here. So x plus 3 bracket 3x minus 2 is greater than 0. Okay, so looking at this, we're looking for what we call the critical values, the point where it crosses the axis. And the point where it crosses the axis when it equals 0. So we're looking here at these two coordinates. So I've got minus 3 here. So either this bracket equals 0 or this bracket equals 0. So I've got minus 3 here, or this particular one. Well, if x minus 2, so it'll be 2/3 for this one. So I've got minus 3 or 2/3. So they are my critical values. So these are the points where it crosses the axes. Okay. Now I'm looking at this quadratic. Now that is a positive quadratic equation, which means it takes this particular shape. It takes that shape there. And because I've got minus 3 and 2/3, then this value must be on this side and that value be on that side. And what I am concentrating on, and again here, I said when this is greater than 0. So when are my lines above the x-axis? Well, to the right hand side of this 2/3 and to the left hand side of minus 3. So that means when it's less than minus 3 and it's bigger than 2/3. All right, so I write that down when x is less than minus 3 and bigger than 2/3. So quite complicated in its process, but of course you would hope that with a question like that they'll be providing with lots of marks. All right, so increasing, decreasing quadratic functions introduces A, differentiation, and then B, quadratic inequalities, which is another lesson on maths-school.co.uk, which you might want to have a look at if you're not familiar with this second part of what I've kind of done here.